Hey everybody, this is Larry. This is me doing week 4 of the Leetcode Premium Weekly Challenge. Hit the like button, hit the subscribe button, join my Discord. Let me know what you think about this problem. 624, maximum distance in arrays. You're given M arrays where each array is sorted in ascending order. You can pick up two integers from two different arrays, each array pick one, and calculate the distance. We define the distance between two integers, A and B, to be the absolute difference, A minus B. Return the maximum difference. Okay. Okay, I mean, you know that that is kind of weird, right? Maybe not. I don't know. So you know that the difference. Well, I mean, the maximum difference is going to be, I think, intuitively, and I hope that I don't have to explain this too much because I feel like I've gotten a couple of YouTube comments about saying that I should explain stuff in more detail and talking about like for loops and stuff. And I'm sorry if I don't always talk about for loops, but yeah, I think for this one, I think the key observation that I would say is, I think the key observation I would say is that you want one number to be the biggest number and you want the other number to be the smallest number, right? I think that makes sense. That's reasonable. And of course, if it's already ascending, then you already know where the maximum and the minimum number is for each array. And so, and I would also say that that you only need to keep track of two numbers, right? You only need to keep track of the row that it is from and the number itself. And there's only two cases, right? Well, I guess technically, yeah, depending on how you want to say it, there are 2 or 3 cases, which is that given A and a B, let's just say A is the smaller number, B is the bigger number, and you take the min over all the rows and you take all the max over all the columns, and you could do this in linear time. The only 2 possibilities. One is that they're from the same row, in which case, well, it's no brainer and you have to take the second min, right? Or second max. And the second one is that from different rows, then you're good. You can return home, right? So, there's an easy proof to show that you only need at most 2 mins and 2 max, because basically the idea is that, well, let's say you have, let me just write it out instead of just saying it. Let's say you have min 1, min 2, min 3, to denote the 3 mins. If you have, say, max 1, and you want to get the maximum difference, then max 1 minus min 1, right? Well, let's say they're in the same row. Then what you're going to do? Max 2 minus min 2, or I mean, if you take min 3, where min 3 is bigger than min 2, this is by definition going to be smaller. So you don't even have to consider it. Hopefully that's easy to follow. But yeah, so that means that you only have to keep track of 2 things, or two things for each min and max, and that's pretty much it, right? So let's do it. So for I in rows, a row in a, I can't even do this anymore. Cannot type. But yeah, let's say we have, min 1 is the smaller number. Let's just say none. Min 1 row maybe is equal to none. Min 2 is equal to none. Min 2 row is equal to none. Maybe this is too wordy. Maybe there's an easier way to type it out. But well, look. Yeah, I mean, you can also think about it as a heap of size 2, maybe that's easy as well. But that's just like implementation semantics, right? Like, or synthetic sugar or whatever. Well, that's not synthetic sugar. That's but it makes the implementation easier. So all right, fine. Let's do it that way then. In fact, I'll just do it in sort or something, right? So then you have mins and then max, right? So here, let's just say we have mins dot append, what is it? The row I and also the value, which is row of 0, right? Because that's the min element. And then there's like a insort or something, right? Python insort. Yeah, I think this is just insort is fine. No, is bisect insort or I don't use this very often because it doesn't really come up. So I'm learning it as well. So thanks for learning it with me. So it's bisect insort. Okay, that's what I thought, but that's why I had to look it up. Whoops, no, mince, right? The last element, right? So this is basically we want to insert this into the right thing, and then here as well. If length of mince is greater than 2, we pop from the at the end, right? You could have also done this with like I said, a heap, right? So yeah, and then now basically if the smallest number, oh, this is actually a little bit different because you want to pop from the front for a max, right? Because if you're sorting, okay, how do I want to do that? Pop front. Easy mistake to make though. So yeah, if the smallest element, could also have reversed it maybe, but if the index is equal to the max elements index, then we, like you say, if they're not the same, right? Even though that's a little bit reverse or double negative, but right. So then now you can just return the sum of them. Oh, sorry, not the sum of them. That's not what we want. We want the difference. Well, we already know which one is the bigger number, so we don't even need the absolute value, and then just subtract them. Otherwise, we want to take the max of either the second max minus the min, or the actual max minus the second min, right? That should be good if I do things right. Isn't it pop fun? Deck. What am I thinking of? Pop fun, pop, push fun. Deck, pop fun. Pop left. Alright, wow, I'm just like really bad at programming right now. But yeah, as you can see, you know, it should be okay. Let's give it a minute. Hopefully I didn't make a silly mistake somewhere. Yeah. 1331, huh? That is slower than I thought it would be. I mean, I don't know how. I mean, I guess I'm just a little bit lazy. I mean, you could have win this with a lot of variables, like I said, but the way that I did it is basically just insorting with 2 elements. And what is the complexity here? Even though I did some crazy insorting, the complexity here is going to be linear because this insort or this thing guarantees that they'll, by the time we do the insorting again, insert sort or whatever it's called, it will only have 2 elements, so you can even think about it as just 2 if statements or whatever. Same thing here. So that means that this is going to be constant time, and we do it linear amount of them, and obviously these are constant. So what is the complexity here, right? The space complexity. Well, it's just O of 1 because these will always have at most 3 elements, 2 after you do the pop. So that's only a constant number of variables we care about. Yeah. That's all I have for this one. Let me know what you think, and yeah, stay good, stay healthy. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.